Hello, hello, hello. How we doing today? Hopefully we're doing okay. Yeah, turn this down. How we doing today, Emma? Hope we're doing good. Switch over to my regular cam thingity thing. Alright, there we go. Hello, hello, hello. How we today? I hope we're doing good. Hopefully we're doing outstanding here today. This is going to be hopefully a, I don't know, shorter-ish type of day? Question mark? I guess we'll find out. Maybe. We'll find out. That's the goal. Boop, 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 boop. Are you doing well today? Hopefully everybody doing well. Okay. Check the audio. That. Okay. There we are. Perfect. Everything's working as somewhat intended. Hello, Liwen. Good to see you. I'm doing fantastic. How are you today? How are things over at the Liwen household? Hopefully everything is doing absolutely fantastic. Hopefully everything at home is good. Glad to see you. Good to see you today. Here for another rip-roaring day. We got another couple sections to go underneath our belt. We'll hopefully be joined by Elizabeth and Nick and anyone else who is going to join us, of course. Maybe Ashley will be here today. I don't know, but anybody wants to join in, that's fine. But we can wait for maybe one of those guys to show up, and we'll probably get underway. Yeah, we got a couple sections actually we're going to be doing here today. So, oh, there's Nick. How we doing, Nick? Are you feeling okay? You doing good? Hopefully not too bad. Better than yesterday, but still tired. Always tired. Well, at least at least we can say for certainty that it's better than yesterday. That you feeling a bit better. So that's good to hear at the very least. Hopefully you get a little bit of rest tonight and you can relax a little bit. Hopefully you're also working on catching up with your tad bit behind sort of deal. So we'll find out together, I suppose. Alrighty. Alright, see if Elizabeth comes on by, and then if Elizabeth's here, then we'll go ahead and get started right after that. Usually Elizabeth here gets here on time. She's running a bit behind here today. You guys got any plans for today or tonight, I guess? Are you guys just sitting and chilling at home? That's what I'm doing. I was sitting chilling home. Alright. What is this? Wow. I can do all that? I didn't even know. I have an unban request. By whom? Okay. Not much? Okay, I understand that. Okay. There we go, question mark. I don't really want to go in odd view. X. I do. Okay. Technically, I could be in mod. Not be. I'm gonna be in stream. Okay. This is a little bit easier for me. All right. There we go. All right. So maybe Elizabeth will join us later, but we're gonna go ahead and get started here. And let's get going, ladies and gentlemen. Okay, so let's do some intros. Let's get started, and we're gonna go in here with some new stuff. All right. So one last bit of integration, and then some other stuff here. All right, let's do this. Okay, let's get started today. Welcome back, everybody, to Tuesday. All right. Hopefully, a nice night. In the end, let's go ahead and continue where we left off last time. Last time we finally finished off chapter 6. A lot of sections, chapter 6. 7 sections actually. Precise. And today we're going to be going over the only section here in chapter 7, which is section 7.1, and then we're going to skip right to chapter 8, which is the last chapter, excuse me, of the textbook that we will be covering. Now, I asked you guys yesterday at the end of class about what you wanted to do in terms of the pacing for the remaining of the course. You guys asked, hey, can we go over these sections here? You know, the majority decision was, can we go over these sections here rather quickly in terms of just trying to get, pound out these sections, get these 4 sections done in the next couple of days or so. And then we move on to review here for the final and all that jazz. So I'm still in the process of making the final, so just need to narrow down those questions. It's hard. Okay, but yeah, so we should be good to go, at least in that regard. Yeah, so we're on a good shape. We're in a good shape. All right. In any case, let's go ahead and get these 2 sections out of the way from your decision here, and we'll see what we get. There's not a lot of questions from the homework, by the way, for these 2 particular sections. I believe one section has like 6 problems, the other one has like 5 problems or 6 problems. So there's not a lot of homework questions for each. I think the first one has a lot more. Has 6 questions, but they're a little bit more involved if you're not careful. So we'll go over those a little bit more carefully. So see how that works out. All right. In any case, I'm gonna check that. Okay, so we're gonna go ahead and start here with section 7.1 and 8.1. Let's go to the big board here. Let's talk about it right now. Okay, so this is what we're going to be covering here today. We're going to be doing question number 1. So let's look at question number 1 here. Question 1 says, how do we integrate by parts? Okay, now this is a formula that we have to use if we're integrating by parts, all right? So if we're integrating 2 things, we're just taking it apart one piece at a time. And I want you to look carefully at each part here in these particular formulas. So be sure you write this down or take a screenshot, whatever you want. But again, you will need to kind of get to know this and kind of get to use this appropriately. So here we have the integral of u dv is equal to uv minus the integral of v du. Okay, so that is integration by parts, all right? At least the formula here at the very least. Now what this trick is that you'll pick one function for u and the one other for dv. Okay, so essentially you'll have 2 parts here. Now the way you pick the function for u and the way you pick function for dv, again there's some tips. So just like u substitution, how do we know what to pick for what? Tip number 1 is pick a u in which du is simpler, i.e. Is simpler than u, i.e. the derivative will be easier to work with whatever you pick for u. So if your derivative is super easy after you pick that u, then maybe that's the one you want to choose for you. And tip number 2, which is just as equally as important, dv, regardless of whatever dv is, dv should be easy to integrate. Okay, so dv here should be super easy to integrate. All right, so that is what we are doing here for this particular guy. Now, of course, just like integrating by parts, or integrating by use substitution, this can be a little bit tough to do. So I gave a smattering of problems. I didn't even give application problems for this one. So I was like, you know what? This is already tough enough as it is. I was like, you know what? Just take it easy. So, all right. So here you see these solutions, but obviously we're going to want to arrive at these solutions. Okay, that's what we're after here. So let's get after these solutions here, and we'll see exactly how we can come up with these guys here with integration by parts, okay? And again, we're going to use the tips that we have here in order to go ahead and showcase this off. All right, let's take a gander at the first one. So let's bust out the paint tool. I just want paint. No, not paint 3D. That crashed again. I tried paint 3D in my first class. It didn't work out again. It was working for a while, and then it's like, nope, my computer spiked, and like, oh. All right. In any case, let's all right. So let's do that very first one there. All right, so let's do number 1. We have the integral of x e to the 6x dx. Okay. So let's integrate this by parts here so we can match our answer. Now, again, we're going to have 2 parts here. We're going to have a u. All right, we're going to set that equal to something. And we're going to have a dv. Now, one thing about dv here, specifically about dv, is that dv has to contain dx. Okay, so I will put that down here actually as a little side note here as well. Note dv must equal something, something, so whatever that something is, dx. Okay, so I don't know what that something is. You're going to define what that is, but again, something dx. So that dx is going to be certainly a thing that you're going to want to be a part of. Okay, now let's take a look at our tips here. Okay, I'll move this over to the right. All right, so let's take a look at our tips. Okay, so what should we define u as, and what should we define dv as? Well, let's take a look at our tips. Our tip says pick a u in which du is simpler than u. All right, and where the derivative will be easier to work with whatever you pick for u. And 2, dv should be super easy to integrate. Okay, we're certainly after that as well. Well, you certainly have a couple things that we can work with. Let's see what I think would be a good idea here. What would be easy to integrate? Well, I'll have you guys kind of select what would be easier to integrate here. Again, if you see, that's what we have here. X minus 1 stuff. So, yeah, back. Well, we got choices here. Now, I would assume that e to the 6x dx is actually. We could try that. All right, so we could have that. We could have u is equal to x. Let's try it. Let's see what we get. Maybe we could also try it the other way as well. A lot of different ways to approach this one. So okay, let's met this out here. All right. It says u should be, again, what's the derivative of, so what's the derivative of x? All right, so why don't I ask you guys that? What is the derivative of x? is the derivative of x? One. Okay, good. That's right. Remember, when we take the derivative view here, this will be 1 dx, so don't forget about that. That'll be important. And then we need to find the integral of this. Okay, so we need to find the integral of this guy. All right. So the integral here of e to the 6x dx, we can easily find that as well. You can use a little bit of u substitution for that if you like. You can set this as like e to the u, where u is equal to like 6x. And I wonder if that would make it easier. I was kind of debating about this myself. Yeah, technically you're still going to run into the same issue regardless. All right, so no matter which way you do it, it's going to be the same. All right, so you would go ahead and do the same thing here. Again, essentially at the end of the day, you could set u is equal to 6x, du is equal to 6 dx, divide by 6, do the whole thing here. All right, and what you would get is the integral of e to the u. You get 1/6 e to the u du. All right, so here you would get 1/6 e to the u, which would be 1/6 e to the 6x. All right, so by far and away, this isn't too hard to do, doing that integration for v. So v here, 1/6 e to the 6x. Okay, so that's what we have here for that. All right. Okay, so now we go ahead and apply our formula here. We have u dv is equal to uv minus the integral of v du. So let's put the pieces in place here one at a time. All right, so we have u times v. So we have x times, so that's u, v, which is 1/6 e to the 6x, minus the integral of v du. Let's see. Take a gander at this. v du is 1 dx. Okay, so this is what we have here. We have u times v, all right, minus v du. All right, that's what we have here. So u times v minus v du. Okay, looks a little complicated. I'm not going to disagree, but it does come out to be nice here in the end. All right, now here's the nicest part. Why did we go this direction here? Well, if you multiply by 1 anywhere, 1 times anything is just that, anything. So we can at least take it to the bank that this 1 is not going to do anything. And as for this stuff on the outside, you don't have to worry too much about that stuff on the outside. That's, again, pretty much the same stuff here, so that's fine. We also know that we can bring this 1/6 on the outside. And here's the nicest part, and this is why we choose this specifically. The reason why is because we already know what the integral of e to the 6x is going to be. The integral of e to the 6x is exactly what we have up here. We just found that out by taking the same exact thing. So what we're going to get here is, once again, is we're going to have here 1/6 x e to the 6x minus 1/6, so that 1/6 on the outside. And then if we do the same thing here, just this guy in parentheses, that's why I'm kind of sectioning it off, we're going to get the same 1/6 e to the 6x again. So we get 1/6 e to the 6x one more time for the same exact reasoning we have up top. Then we're going to get plus c out here. Okay. So by doing that here specifically, we're going to get 1/6 x e to the 6x minus 1 over 36 e to the 6x plus c. All right. And that's our final answer for that problem. So if we look back at our guy here, this is the same answer, by the way, as what we have down here. Just this is super simplified now, but in reality, we have the same thing. Are there any questions about that? Any questions? Let me zoom this out. There we go. Process here. Questions, questions, questions. You guys okay? Hopefully that wasn't too overwhelming. And I'll stop for just a second. No? Again, feel free to ask me questions if you're not sure exactly what's going on. Otherwise, I'll move forward with the next question. Alright, number 2 is pretty similar, but let's try number... Let's see, which one would... Let's try number 3. Okay, so let's do number 3. That'll be the next one here, if there are no questions. Okay. Let's go to question number 3 here. Question 3 asks, what is the integral of x times x plus 8 to the negative 3/2 dx? Alright, so we have a u and we have a dv. Got to define both here right away. Alright, so can you tell me what should u equal and what should dv equal? What should u equal here first? What should u equal? Go. What do you think would be easy to take the derivative of, and where we would get an easy answer? What do you think? Be an easy one. You got a couple choices, so again, should u equal here? Nick or Emma or Lee Wen? You guys got a particular answer for me? X? Okay, that's right. Let's pick X. X is a pretty easy one to basically pick. Alright. So if we take the derivative of x again, that's going to be 1. Alright. So that'll be 1 dx. Alright, so that's fine. That means by default that dv here is going to be this whole thing here of x plus 8 to the negative 3 halves. All right, so again, we're just picking functions here. We're not just picking functions here. So we got dv is x plus 8 to the negative 3 halves dx. Now, of course, our goal is to go ahead and find the integral of x plus 8 to the negative 3 halves. So at least let's find that out first. So in this case here, again, use u substitution here. You can substitute this this guy. Let's call it a different letter this time. Let's call it g. G substitution. Let's say g here is equal to x plus 8. Okay. So then we would have the integral of g to the minus 3 halves. Right? That means that g prime is going to be, or dg, whichever way you want to call it. Let's call it dg, actually. That's probably more appropriate. Same thing, but consistent. Alright, so dg here will be equal to 1 dx. So at the end of the day, dg equals dx, so here we can just replace this dx with dg. Take that integral there. So that integral is going to be, in this case, x, was that, to the negative 1/2, right? So we have g to the minus 1/2 over negative 1/2, added 1. If we flip this around, that's going to be negative 2, g to the minus 1/2, or now replacing everything down, negative 2 times x plus 8, the negative 1/2 power. Okay, so that's going to be our v is negative 2 times x plus 8, the negative 1/2 power. Okay, sounds like a plan. All right, good stuff. All right, now that we have that, let's go ahead and take a look here at the next part, which is again doing a uv minus v du. So again, we're going to take our two guys here. We have uv minus the integral of v du. So, oops. So we have u, which is going to be x. We have x times negative 2, x plus 8 to the negative 1/2. That's uv minus the integral of v. All right. Du. Du here is going to be just 1 times dx. That's fine. Okay, that sounds great to me. All right, so let's see what happens here in this instance. So in this instance here, let's go ahead and see what we get. So again, here we get minus 2x times this x plus 8 to the minus 1/2. That's not going to do much. As for this next part here, we have minus, and we have this big expression here. Again, 1 dx is just dx because 1 doesn't do anything. We can bring this negative 2 on the outside. That's perfectly fine. We'll have the integral here of x plus 8 to the negative 1/2 dx. Okay. And so, again, this can become positive too. If you feel like doing that, you can go ahead and do that. Negative 2. So, again, if you want to take the integral of x plus 8 to the negative 1/2, it works pretty much the same way as it did in the previous part. Again, you're just doing the same kind of little substitution games. So we have negative 2x, x plus 8 to the negative 1/2, plus, in this case, plus. Actually, let's make, you know what? I'm going to make that minus, actually. Make that minus negative 2 so we can at least preserve the sign so it makes it less confusing. Let's not make it too confusing, though. We'll keep it as is for right now. Alright, so this is going to be, what is that? Again, we do u is equal to x plus 8. Take the integral of u to the minus 1/2, so that's positive u to the 1/2. That's going to be x plus 8 to the positive 1/2 over 1/2. Alright, plus c. So we get negative 2x, x plus 8 to the negative 1/2. Flip that 2 over, becomes minus negative 4. Okay, again, this negative 2 divided by 1/2 is negative 4. That's where I'm getting that from. And here I get x plus 8, the 1/2 power, plus c. And then I can change the sign here. I can have negative 2x, x plus 8 to the negative 1/2, plus 4 times x plus 8 to the positive 1/2, plus c. Okay, and that is the end of the problem for that. Yeah. All right. Any questions about that? Any questions? All right. Any questions? Any questions at all? No? Okay. So, all right. If there are no questions, that's fine. I'll keep moving forward if there are no questions. So, just going to go ahead and show that off there. Okay. It's a lot of information. It feels it makes sense. Yeah, it's just using those past techniques that we learned in substitution, and now we're applying them in this particular case. Now I'm gonna let you guys pick the next one. You guys can pick either for the last question here for this section. It's either 4 or 5. So you guys can pick one of those two. Either pick number 4 or pick number 5, and we'll go over that question there. So, number 5. Okay, let's see what. All right, so Emma says number 5. Let's see what Lee Wen or Nick have to say if they would like number 4 or number 5. 4 or number 5? Number 4 looks harder to me, so that one. Okay. It looks like the tie-breaking vote will go to you, Lee Wen. You want to do number 4 or number 5? See if Lee wins. Lee wins here. I'm not sure. She's in a little bit of a delay. Maybe she stepped out. I don't know. Oh, looks like she stepped out here. All right. All right. Which one is tougher in my opinion? Let's take a look. Oh, okay. I know which one is actually tougher. So the tougher of these two problems here is number 5. All right, but I will tell you this, Nick, about number 4, because you said that one does look a little tough. The trick to number 4 here is when you're defining u in dv, u here is going to be equal to the natural log of 8x. And the reason is because if you chose, and dv here is going to be equal to x squared dx. So the reason why you actually have to do it this way is because you don't know what the integral of the natural log of 8x is. There's no way to go ahead and find that. We don't have any tools available for us to find that here. So because you cannot find the integral of natural log of 8x, you're going to make that the one you'll take the derivative of instead, and then repeat this process here. It actually turns out to be pretty nice. So that one there can be easily done once you define your u and dv in that way, Nick. So that'll be a bit easier to handle, at least from where I'm sitting. So let's do number 5 then. All right, so number 5 says, number 5 goes the integral here of, oops, I accidentally covered it. Integral of 6x over root 4x plus 6. Okay. So let's go over this one here. We'll go over this carefully, right? Like everything else, no problem. Okay, so what do we want to do first here? Well, again, we're going to define our u and dv. So let's do that here first. Again, we want to pick a function we can easily integrate. And then we want to pick a function that is easy to take a derivative of. At least we hope we can. Again, keep in mind about the formula here, so don't want to make this super complicated if we can avoid it. So what we're going to do here is we're going to go ahead and we're going to take dv as our as this guy right here. Now, what can be helpful here, by the way, and I'm just going to point this out here, so that way it's clear about how I'm going to define dv. Remember that this can be rewritten as 6x, all right, as one expression. And you could always move that square root to the top there, and so technically you can make it as 4x plus 6 to the negative 1/2. So don't forget, you can actually make it like that, and that's perfectly acceptable, okay? I'm just pointing that out there about that because this does prove to be fairly helpful here in this problem. All right, so for dv, I'm actually going to go ahead and pick the possible yuckier one here. But taking the integral here is a little bit easier. It's actually easy. We'll do 6x for this. Technically, yeah, you could, yeah. 6 out of 3, yeah. That turns into problems. All right. So you could try again. U is 6x, easy to take the derivative of. All right, if we take the derivative of 6x, that's 6. Now we want to find the integral here of 4x plus 6 to the 1/2 power. Let's do a little side scratch work here. Again, let's do g substitution. All right, so g here is going to be equal to 4x plus 6. And then we take dg is equal to 4 dx. Okay, so we're going to divide by 4 here. So what we have here is we got sorry about that. Put this. We got the integral here of u to the negative 1/2. Du is going to be or d and dx or dg, whatever you want to call it. X g to the gotta remember I keep using g. I'm so used to using u. We have 1/4 dg. All right. You can bring that 1/4 to the outside here. 1/4 g to the 1/2 dg. So we take that guy, at g to the minus 1/2. Excuse me. We have 1/4 g to the positive 1/2 over 1/2. Hey, James! James, my friend! Hey, how you guys doing? Hey, thank you for the raid! Oh my gosh. I hope all of you are doing fantastic today. Integration, I know, but I gotta do it, my dude. Taylor, I gotta do it. Integration. It's a integration by parts today. Hey, James, how are you? I hope you're doing well. I hope you're doing well, James. I hope today was a good day for you. Been a little busy on my end as I've been kind of working back and forth, but yeah. Been I kind of like calculus. Cool. Yeah, calculus can be math. Raw math. That's true. Great day. Good. Good. That's good to hear, my friend. That's very good to hear. I hope you and Rach are doing absolutely fantastic. I know things have been busy for you with doing hashtag stuff and, with the season starting to gear up. But, I know that things have been, hopefully you've been able to relax a little bit and just kind of be able to walk outside a little bit more. You got a few more days before the official supposed lockdown is over. So, hopefully that'll come to pass and things will be all right. How have it been? I've been fantastic, my friend. Absolutely fantastic. 100% fantastic. It's been it's been productive. It's been productive. Hey Taylor, have a great night. Much love to you as well. Take care of yourself, my friend. Got 1/4 over 1/2. Interesting. All right. 1/4 over 1/2 is going to be 2 times 1/4, by the way. So that's going to be 1/2. G to the 1/2. So you get 1/2 here, and then you get 4x. What is that? 4x plus 6. Positive 1/2. Yeah, James. You got plans for this week? Are you going to be out and about for preseason games? And got the regular season coming up, so I'm sure you're going to be doing a lot of video editing and whatnot. So yeah, I don't know what else you've been up to there, James. But besides, of course, Warzone and all that stuff. But I genuinely hope you've been enjoying yourself and collecting that quid. It's all for the hustle. Just had an ad. Oh, okay. No, it's okay. No, have you been busy with hashtag, James? You're busy with hashtag, or are you getting busy? You've been able to step outside the house, kind of lockdown's gonna be over soon. You got a lot of things I'm sure prepared or preparing to do. So I guess that was my question to you: is if you had uh, if you had stuff going on in that regard. You know, what do I have here? I have U V minus V. Okay, so let's put that together there. So I got U times V, 1/2 4x plus 6 to the 1/2. You gotta tell me what you've been up to, James, or at least you're isolating? Were you exposed to somebody who has COVID? Usually that's the reason why you isolate, at least for the most part. I know you've been trying to get the vaccine fairly soon, so hopefully you've been able to get access to that. So uv minus the integral of v du. Been told to by the NHS app, yeah. No idea if I have. You know what, James? I know that you have the NHS app, right? But the one thing that I've always professed to, at least in that regard, is healthcare and whatnot. Is like you just get it from the source itself. I would just call like a local, wherever your local institution is, and just be like, am I even scheduled? You got to talk to a person. I don't think an app's going to necessarily, because I think that usually sometimes when you try and plan things ahead like that, it's really there's like chaos all behind the scenes. So I would talk to a person, get it done in person, and then get your first shot. That's always want to get that done there. This is the integral of v du. That's basically like when I got my. You've had your shot, okay? You've had one shot or two shots. I believe you told me you had one shot, right? Maybe I'm wrong. I thought you said you had one shot. Yeah, just the one. Okay, so you're just waiting for the second one. Yeah. Okay. Yeah, you get the second shot, you'll be fine. Hopefully. Second shot really kicked me in the ass, so I was down for the count for the weekend. But once the weekend had passed, here you go. They will ask you to isolate if you call. Oh, they'll just ask you to isolate? That's so weird. I mean, 9 more days, man. 9 more days. I think that's the countdown. Better safe than sorry, that's true. I don't disagree with you, James. It is to be better to be safe than sorry with Corona Chan. I agree with that. It's just you know yeah, it's just like how much is I agree. You're trying to limit the spread and everything, and it's effective. Isolating and wearing a mask and everything like that. Like all that stuff, I 100% agree is effective. It's just that at this point, the question I always ask about coronavirus is this. And that is, at this point, is it like the common cold, where there's just going to be so many variants that you basically are going to be fighting on too many fronts to really stop it? Because I just think that, like any virus, it's going to mutate, adjust to its environment. And you can only come up with X amount of vaccines if you have like so many mutations per year. You're gonna have to, I don't know if there can be a one size, like a one shot, flu vaccine. Maybe in that regard where they inject a few flu strains. But I don't know if a coronavirus is going to work the same way as, say, a flu strain, where you have multiple flu strains and you're supposed to build up an immunity in that regard. So the thing is, for me, is like, yeah, you're trying to do the same thing here, but can you keep up with the amount of mutations that have occurred in the past year and a half since, or 2 years? Going to be going on 2 years at the end of this year. With something pretty much brand new. That's kind of like my thing is like, and do you have to continue isolating? Do you have to continue? It's like, is it going to be too much on the mental strain of the population? That's also my thing there. So I want you to stay as safe as possible, obviously, but that's the thing I always am curious about is the long term effects it has on people. So better to be safe than sorry, true. But just one of those thoughts that I've had. Let's go ahead and see what we got here. We have you feel free to chime in with your opinion there, James. 100%, man. Here we got 6 times 1/2. That's 3x. We got 4x plus 6, the 1/2 power. We can take this 6 and this 1/2 out. That's going to be 3. 6 times 1/2 is 3. Integral of 4x plus 6. This should be to the 1/2. I think that's for the 1, right? Yeah. Yes. Okay, so this is what we have here so far as we put this together. Okay. All right, so then we just have to find the integral of 4x to the 1/2. Again, works the same way as we just did here for the previous integral. So let's just rinse and repeat that. So we get 3x, and we get 4x plus 6 to the 1/2 minus 3 times 1/4. Because again, just the same thing, 1/4, and 4x plus 6, and then we just add 1 to that. Oh, and we gotta divide that. It's gonna be 3/2 all over 3/2. We got a little bit to do there. Plus c. Yeah, mental health is super important, so I always want to keep that in mind, James. Everyone's mental health is very important. I feel that people are kind of frayed after all that stuff. So it's really that I want to get things kind of getting back to normal a little bit. 3 times 1/4 is 3/4. 3/4 divided by 3/2. So that's going to be 6 over 12. That's going to be 1/2. Okay, so I get minus 1/2, 4x plus 6 to the 3/2 plus c. All right, and that's going to be our final answer for this. There we go. There we are. All right. Good stuff. Yep. Any questions? Any questions at all? Wow, that's a super simplified form. But okay, why not? That's an x there, right? Yeah, that's an x, and then 1/2, and yeah, it's a super simplified form of what I've just done. Okay, got it. Any questions? Any questions at all? Want to be sure everybody's okay. Any questions? Any questions that you may have? Do you have a good stream? I hope you had a good stream, James. I hope you had a good stream. Man. Yeah, it was good. What'd you guys do? Warzone? Did you guys win? At least some Rebirth Island? Not as of now. 100% on Ratchet and Clank? Ooh, wow. You going for 100% achievements, like grabbing every single little bit and item? I could see you, James, as a total completionist. Like you have to get like you're not satisfied until you have to get every little bit. Yeah, you did it all. Oh man, congratulations, dude. That's awesome. The super completionist run. I respect the hustle, my friend. I respect the hustle. Yeah, you could join me on Platinum Trophy. You got that? Platinum Trophy. That's right. Platinum Trophy just as hard to get as a shiny Pokemon, right? I need shinies. I need shiny Pokemon. All right? That's what I need. Shiny Pokemon. Super important to my life. All right? Everyone needs shiny Pokemon in their life. All right? If you don't have shiny Pokemon in your life, I don't know what you've been doing. All right? You need to stop what you're doing. Stop what you're doing. Shiny Pokemon. Please. Okay. So that All right, so that is the first section right there. That will take care of the first part there. So let's do the next part here. Alrighty. Okay, so we're gonna go and do the next question here. The next question is even easier. James, even I know you can understand what I'm about to do. I know you can understand what I'm about to do. I bet you can understand calculus too, James. I trust you can. 100%. All right. Let's do the next part here. No chance? No, no, no. Tell you what, James. I bet you a fiver that you can understand exactly what I'm going to be saying here within the next 20 minutes. I guarantee it. I guarantee it. Okay, bet. All right, good. All right, so let's go to the next section here. All right, so the next section here is going to be talking about functions of two variables. All right, so functions of two variables. That's all we're going to be doing here for chapter 8.1 and section 8.1 here. So we're just going to be we're just have two variables here instead of one. Usually you have f of x is equal to something x plus whatever. That's what you usually have for functions. However, now we can put functions in two variables, i.e. two letters. So what's the notation here for a function in two variables? Well, the notation here is f of x comma y. So instead of just f of x, it's now f of x comma y. Now you could put any letters you want in there. You could put, instead of f, you could have g. Instead of x and y, you could put w and z. It doesn't really matter. As long as they're put in those letters, that's fine. Now some examples of a function in two variables would be something like this. 3x squared minus 9xy plus 2y minus 5. All right, that's a function. It's in two variables, two letters, i.e. same deal. 5y minus 9xy squared plus 2x squared y. This is just random stuff that I just kind of made up off the top of my head. Really, not really that hard in all honesty. Okay, well, now you understand how things are in two variables and what they generically look like. Fine. So, what do you got to do? Well, what are we going to do with them? We're going to evaluate them. How do we evaluate them? Well, all you got to do is plug in the values in each respective variable based on the order that they're written for the function. What does that mean? Well, let's take a look and let's see how this works. It really is super easy. Like, I think that at least this is like super easy. Like, they devoted an entire section to this, and I'm like, okay, I can roll with this. That's perfectly fine by me. I don't have to do as much. All right, so let's go over number two. Or number two. Number one is even easier than that. Number two is f of x comma y is equal to 6x squared plus 8xy minus 5x plus 5. All right, so this is our function here, all right, in two variables. Now, the first one that they ask us to do is find of f of 1, comma 2. Okay, so all you got to do, super simple James, super simple Emma, super simple Lee Wen, super simple Nick, super simple Elizabeth, super simple for anyone else there in the chat. Super simple. I guarantee you, all you gotta do is plug in 1 in for X and 2 in for Y and just start evaluating. So let's just plug it in first. So we got 1 in for X. Remember, anything we plug in, we got to put parentheses around. We get 8 times X, which is 1, Y, which is 2, minus 5, which is 1, and then plus 5. And we're just gonna see what we get for our answer. All right. We do 1 squared first, so we do 6 times that 1 squared, which is 1. I'm going to do this out here. 8 times 1 times 2 is 16. Minus 5 plus 5. All right, so here we got, if we were doing BIDMAS, I'm going to show you a problem, James, just a second. I've showed this problem off before, but I'll show you a problem here. If I want to test your BIDMAS, I got a better one. All right, so 6 plus 16 minus 5 plus 5. If we do that, that's going to be 22. Okay. James, I got a problem for you. Let me test your BIDMAS, okay? Let me see where you're at with your BIDMAS, all right? From way back in the day. Can you tell me what is the answer to this problem? 6 divided by 3 times 2. What's the answer to that problem? I would like to know what is the answer to 6 divided by 3 plus, times 2, James? That is your question. I want some conviction, James. I want conviction. All right, you're either gonna get one or two answers. Conviction. You're gonna either pick one or two answers. You know that there's only one or two answers. So you gonna either put that number and period. I want to see if you got that right. You think it's 4. And you, my good sir, would think it's 4. You, my good sir, would be absolutely correct. That is correct. The answer is indeed 4. That is correct. Multiplication, division. Okay, if I did this. What if I did this, though? Yeah, let's do that. Would you do division before multiplication? I'm going to ask you that question. Would you do division before multiplication in this case? Let's make that 2. Let's make that 2. Say if this was 2. Say this was 2. So that you would do, so the answer for you would be 6, correct? So would the answer be 6? So you would do this first before you do multiplication, is that correct? Okay. And the answer to that is no. Actually, the answer is still 6. That part is true. But you have to do multiplication. Remember, one of the things about BIDMAS, or PEMDAS as is said over here across the pond, is multiplication division are the same rank. Okay. One of the things that is always true and what always trips up people about some of those basics math is that if you read it from left to, if you did addition subtraction there, James, right? If you did 6 plus 2 minus 3, you would go from left to right. You do 6 plus 2 is 8 minus 3 is 5. And you'd be like, okay, I'm going to do that. Well, if you did like 6 minus 3 plus 2, you do the same thing. You do 6 minus 3, which is 3 plus 2, which is 5. You would go from left to right. You do the same thing with multiplication and division. There's no difference at all. None whatsoever. People think that there is because D comes before M in BIDMAS, or in over here in the US, M comes before D when it comes to PEMDAS. But in actuality, the reality is that they're actually the same rank and should be read from left to right if there are no parentheses. Yeah, so it's one of those tricky things that people often forget about for little things like that. It's just that, yeah, they are the same. They are the same rank. So based on how we actually rank them, that's actually something that we cannot forget for certain. Okay, now let's try the next one here. All right, let's do another one here. Let's do -1 comma 2. That's the next one here. All right, it's bigger. Okay, so we do -1 comma 2. All we gotta do is plug in -1 in for x. We get -1 squared. Remember, always parentheses around what you substitute. This is especially true for sign changes. 8 times -1 times y, which is 2, minus 5 times was x, so -1, plus 5. Let's do this out. Do the exponent first. That's -1 squared, which is 1. So this is 6. 8 times -1 minus 8 times 2 minus 16. -5 times -1 is going to be positive 5. And here we get another 5. So here we get 0. Okay. All right. Easy peasy lemon squeezy. Yeah. That's not too bad. Hopefully that's pretty simple. We'll do number 4 though, because number 4 uses properties there. Questions about that? Any questions? Hopefully that was easy. Any questions so far? Any questions, James? It's so nice to see easy math. You're right. Nick's like, this is so easy, man. You're like, bro, you got that right. Nick's been missing this for like 3 weeks. Oh man, I feel you, buddy. I feel you. I totally feel you. James, you have any questions? You're part of the class now. If you got any questions, you let me know. Or you could just type no in the chat if you just want to let me know. Oh, no questions. All right. So am I to understand that you understood exactly what I did? Oh, well, that's actually good. Maybe that means I won that fiver already. Very good. Looks like I have 5 quid heading my way. I'm just gonna say. Ah, easy time, easy life. Why do you think I asked the question to you, James? My good sir, you have been played for 5 quid. You messed with the mathematician. That's what you get. All right. H H of E comma 1. All right, so E here is S and 1 here is T. So we're just going to put S, we're going to put S, we're going to put E in those places, and we're just going to put T, we're going to put 1 in those places. So 5 times E times the natural log of 1 minus 9 times T, which is 1, times the natural log of E. Okay, so just as a friendly reminder for you guys in regards to this, remember natural log of 1 here is equal to 0, okay, and natural log of E here is equal to 1, right? So a couple of those log properties there. Ipalo, hello, how are you doing, my friend? I hope you're doing fantastic. All right. Okay, let's go ahead and finish this off here. We get 5 times E times natural log of 1, which is 0, minus 9 times 1 times 1. Okay. You think you'll sleep? All right. If you're tired, my dude, then go to bed. That's perfectly fine. All right, we get 0 minus 9, so we get negative 9. All right. Easy peasy lemon squeezy. It's 2 p.m. in Italy. Were you up all night? If it's 2 p.m. in Italy, then maybe there you go. Oh, it's 2 a.m. Okay, you put 2 p.m. and I'm like, okay. By the way, DePaulo, I was rooting for England, but I want to say congratulations to Italy on a wonderful final. So, congratulations to your home country. You guys played very, very well, and it was a thrilling match. And I want to, you know, two wonderful teams, but congratulations to Italy. Great job, guys. Yeah, no problem, man. No problem, of course. Well, I'm American, so I suppose that doesn't really count. But I'll be honest, I was rooting for England because I have, my good buddy James from England. I got, got a lot of buddies in England. But I no, seriously though, I mean, look, when it comes to rivalries, we all have rivalries here in sports and whatnot, but it shouldn't get to a point where you should always you should be, it should be ugly. It should be good sportsmanship on both sides. It was a thrilling match. The fans enjoyed it. A lot of people had fun watching the Euro 2020 final, and Italy came out to be the top team, the best team in Europe for 2020, and yeah, we should celebrate victory. We should celebrate, everybody who played. It could have gone either way. It was just overall that's just how the dice rolled out. So I mean, you know what? Fair play to everybody. That's how you should act as a fan. You should act, that yes, you're upset that your team didn't win, but take a little time, mourn in the loss, and then instead of acting angry, congratulate the other team for playing really well because it's a sport, and you should do that. We have me. I follow the Copa America. Not much. I mean, I'll be honest. The U.S. team has been kind of up and down. Uh, Unfortunately, the men's national team isn't great. I mean, obviously we have the rivalry with Mexico, but the biggest problem there, DePaulo, and I think you already know, is that the quality of play here, if you look at North America compared to South America, of course, two different stories, is that the quality of play is just not even remotely close to what you find in Europe or what you find in South America. You know, I mean that's why the World Cup is so good. It is what it is. It whittles out. Yeah, there's just that really large talent gap that can't be matched at this moment in time. The U.S. has the best women's soccer team or women's football team, whatever you want to call it, but yeah, in terms of the men's, there's still that huge difference. It's huge, that huge gap. It's starting to get better where men are starting to get, being signed to European contracts and European leagues, like Christian Pulisic being the most prominent over in Chelsea. But it's been a very slow roll for U.S. men to be put on European teams. It's been a very slow roll. So, you know, it may take another decade before you start to see more consistent talent from the United States start to make their way into more European competitions where they're going to raise their level of play and have tougher competition. Um, and then that may translate over here when they come back here for like maybe international duty. So just depends. It's been very, 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 very slow. It might be Copa Pseudo America. America. Yeah, right. Yeah, that's true. I wish we could play it. I wish we could play Italy. On a yearly basis or on a by in every couple of years. To have that Italy or England or any team, where we're going to have that higher quality level of play and where our players have to reach up and because right now all it is just what U.S. and Mexico. That's basically what you talk about. Maybe Panama or Honduras, but yeah, it's just there's not a lot to there's not a lot here for quality of uh, competition. MLS is a different story, but that's a league. Quality of competition is a little bit different. Let's see here. What else am I doing? Oh yeah, that was the one I wanted to do. -9. Uh, okay. Now the other two questions here, just to let you know, the other two questions here are basically they're basically the same type of questions. You're just plugging in the values into your functions, and that's all you really need to do. It's pretty much that easy. So yeah, good stuff. Hey, DePaulo, you have yourself a good one. We'll see you tomorrow, my friend. All right. So for this one here, you plug it into P, and you get the first one. You plug it into Q, you get the second one. That one's pretty simple. Same with the last one there. You're just plugging in these two numbers. 243 on labor, so that'd be X, and 1024, 1 trillion on capital, that'd be Y. Okay, so not much going on there. If you want me to do a problem, I can, but totally up to you. If you'd like me to do either 5 or 6, you guys pick 5 or 6, and I'll gladly do it. Otherwise, there's not really a whole lot going on in each of these problems. It's, again, pretty straightforward without too much effort whatsoever. So, um, any questions? That's all you have to do for this section, for section 8.1. That's all I'm going to ask you to do. There's another half to this with curves and stuff, but that's fine. Can we do a little bit of 5? Yeah, sure. I have no problem with that. Easy time, easy life. Let's do it. All right. Country Workshop manufactures both finished and unfinished furniture at home. The estimated quantities demanded each week for its roll-top desks in the finished and unfinished versions are X and Y units, when the corresponding unit prices are P equals that and Q equals that, dollars respectively. For the weekly total revenue function, RXY. All right, so here we have the finished and unfinished versions. All right. Okay, so, all right, gotta make sure. All right. Okay, so for the weekly total revenue function RXY, compute the values of R8040 and R4080. All right, that's fine. So let's go ahead and plug it in, and well, let's see what we get. Why not? Um, estimated quantities demanded for each week of this roll top test. Okay, so this is the estimated quantities that are demanded. Wonder if I have to add that up together. Well, I'll figure it out. All right. Anyway, that'll matter. Let's do. All right. So let's go ahead and plug in 80, and let's plug in 40, and let's see what we get here from the finished pieces here. So manufacturers are both finished. Yeah, that's right. Okay. Check one thing. I want to check if I have to actually multiply by something else on that. That one there, I think you have to multiply by it. I'll make double extra sure about. Yeah. Okay. That's fine. All right. Yeah. Was that? Yeah. All right. All right. So there's only one thing that we have to do for this. We'll just need to make one little tweak here, and okay, headphones. Go over there, so I don't have to do that again. That'd be great. Thank you. Okay. So the revenue. How are we going to do the revenue here for number 5? So the way the revenue works here, at least in terms of a function of x comma y, is if we're going to use this p and q, we're going to use a little bit of a formula here. We're going to use xp plus yq, or q times y, whichever way you want to call it. So q times y. So xp times yq, or q. Actually, I don't know why I put that way. All right, yq. So if we're going to do that here, we're going to have x times p, which is 200 minus 1/5 x minus 1/10 y. All right. And we're going to go ahead and add to that y times q, which is 160 minus 1/10 x minus 1/4 y. And so all we're going to do here is you have the option here to simplify this if you like. It doesn't really matter because you're just plugging in 80 and 40 in for x and y. So it's up to you about how you want to approach it. If you want to distribute and then add like terms and stuff like that, that's cool. You can go ahead and do that. All right. But if you're doing r of 80, 40, for example, all right, that's the first one there, then just plug in 80 for x and 40 in for y and just solve it outright. So for example here, notice you have 80 here for x. That's the first thing we're going to put in. And then here in the brackets, we could put 200 minus 1/5 times x, which is 80. And then minus 1/10 times 40, which is y. Then we'll add to that the 40, which is y. And then 160, we'll put that in brackets. 160 minus 1/10 x, which is 80. And then what do we have here? Minus 1/4 y. 1/4 times 40. So that's all we pretty much have to do here. Now if we figure this out, we're going to get 80 on the outside here. You get 200, was that 80 divided by 5? That's going to be 14, 15, 16, so that's 16. Here we have 40 divided by 10, which is 4. All right, so we have that. Plus 40 times a bracket here, 160. 160, 80, 10, that's going to be 8. And then we have minus 10. Okay, so let's see what we get here. We get 80 times, that's going to be 184. That's going to be 180. Plus 40. Is that 18? 18, that's going to be 42. 142. All right, let's see what we get here. So, bip bop boop in the calculator. So here we get 20,080. All right, so how would you answer this question here in this instance? Well, it asks us first, let's put in the answer here. Put in the right answer, that'd be great. We'll submit this. See what we get here. Okay, so 20,080 is the correct answer. So the real question is, well, what do you put in for the next part there? You know, what do you put in for the blanks here? At least in this case. Well, this one's it's as easy as it sounds there, Emma. So basically, what you do is you say R8040 says that the revenue sales from 80 of the finished and 40 of the unfinished. Again, 80 is first, 40 is second. Per week, the revenue that you get from that is the answer that you have up top, which is 20,080. And so if we bit bop boop that, and that is correct. So you can see how number 5 goes, and then you just rinse and repeat with the numbers flipped around, 40 in for X and 80 in for Y, and you'll be able to solve for that lickety split. No problemo. Look at James run away. Now James owes me a $5. Oh, James, I will not forget the $5 you. All right. Any questions about that? Any questions at all? Oh boy. I think I did more talking, just talking about other stuff than actual stuff. Who knew? All right. Any questions, Emma? Nick? Lewin, Elizabeth, anyone else? Anybody have any questions? No. No? Okay. Nick, any questions, or is that pretty easy peasy? Nope. All right. Just remember that for that last example there. Just remember to use this little guy. All right. Okay. Very good. Very good, you guys. All right. That'll take care of those 2 sections here for today. We are DONE done. All right. Very good. Very good. You guys, absolutely outstanding today. You guys, absolutely wonderful. All right. I respect the hustle 100%. Guys, thank you so much for coming on here to the stream once again. I appreciate you. I love you. You guys are absolutely fantastic. And we are coming down to the very final 2 sections of the textbook. Okay, so we have sections 8.2 and 8.3 to go, and then that is it, ladies and gentlemen. That is it for the new material. It will be done. And remember, after that point in time, once we're done with that new material here, either tomorrow or at the end of the week, remember that we will be going over review questions for any and all the homework stuff that you may have. Whatever you got, we're gonna go over those type of questions there, so we can talk about it. We'll discuss it, and we'll see how it goes. Okay. That's my promise to you, and of course that's what we're going to be doing here. Probably, well, more than likely definitely for the next 2 weeks. So, but we gotta get the new stuff done here first. Let's get that done and dusted. Moving forward, starting tomorrow. Last 2 sections, folks. All right. So that'll take care for today, everybody. Thank you so very much. All right. Thank you for making me richer, like by five British pounds. I'm being owed a $5, so that's very important. Thank you, Emma. Thank you, Emma. Thank you, Nick. Thank you, everyone who decided to come out to stream here today. You guys are absolutely fantastic. All right. Thank you so, so very much. I really, really genuinely appreciate it. All right. We will see you all tomorrow. Same time, same place, everybody. Take care of yourselves. And as always, stay safe, stay healthy, but most importantly, stay sane. Have yourself a wonderful night, everyone. And we'll see you here right bright and in the evening. All right. Have a great one, everybody. Well, we will see you later. Take care, everybody. Bye. Bye, everybody.